On this problem, we're given just some very small amount of information, and it feels like we don't have enough information for the problem. You're given BD is congruent to CD. I always like to try to decide what that means to me if I'm given that information. And what it means to me is that this arc is congruent to that arc, and BCD is an isosceles triangle. I'm given that ABD is 20. And so now I've got to try to figure out what does that mean. And so I'm going to have to work with this 20 because I don't have any diameters in, which means I can't find right angles. And so what am I going to do? Well, when you can't find anything else, it's always a good idea to draw in radius. And if you draw in this radius here, you realize, oh, wait a second, I've got a isosceles triangle, which means this angle here is 20, and that angle is 140 because of 20 plus 20 is 40, 180 minus 40 is 140, which then tells us arc BD, because BAD is a central angle, arc BD is the arc, so it's 140. And then because we know the arcs were congruent, we know this is 140. And so now we do 360 minus 140 minus 140. So 360 minus 280 to find this arc. And now all of a sudden we've got lots of information about this problem. We have all the arcs. And we can now find the angles because all three of these angles are inscribed. And so angle C is just half of 140. Angle B is also half of 140, which means this would be 50 if we needed to know it. And then angle D here is just half of the 80, which would be 40. So arc DBC would be 140 plus 80, so 220, because that's this part. Angle BDC is going to be 40, and angle BCD is 70. And having worked through this problem, we went from having almost no information. By drawing in a radius, we had lots and lots of information. Always a good strategy when solving these problems.